Bismillahirrahmanirrahim. Assalamu alaikum. Good morning, dear student. Today we are going to discuss about the accuracy and precision. If you look into your textbook, you can see that it's mentioned over here. We will discuss about section 3, chapter 2. It's related to the using scientific measurements. And the very first thing we are going to discuss about is accuracy is different from precision. And the second part that we will discuss today is significant figures are those measured precisely plus one estimated digits. All these things we will discuss by today. And let me start from the very first one, accuracy and precision. Accuracy refers to the closeness of measurement to the correct or accepted values of the quantity measured, while the precision refers to the closeness of the set of measurements of the same quantity made in the same way. If you look into this figure 3.1 over here, you can see that this one is all about the darts over here now, the arrows in the darts now. If you look into this one, this is the actual position where a person have to hit these arrows into these darts. So if you look over here, all these four arrows are going to hit the center of this dart. So we can say that this is very accurate now. Also, all these arrows are very next to each other, so it means that it is highly precise and highly accurate. While if you're moving toward this one, these arrows are hitting over here, not the central part of this these darts. So what we can say that it is not accurate, because when this one is going to hit this actual position over here, we can say that it is accurate. So over here, the accuracy is low, while all the arrows are very nearer to each other, so it is highly precise. Now in this case, neither the arrows are going to hit the center part, neither they are very close to each other, so we can say that the precision is low, also the accuracy is low over here. And in this case, although these arrows are somehow nearer to this part, the central part, look, this one is very nearer to this one. So we can say that the accuracy is somehow high on average, but the precision is very low because all of these are very far away from each other. If I'm going to give you some examples like if I'm going to ask from students to estimate my age, what is my correct age? Let some of the students said to me that I am 32 years old. Some students said that I'm 31-year-old. Or one student said to me that I'm 30-year-old, and some students said to me I'm 29 years old. While in actual, the age of mine is 31 years. This is the actual age. So if you look over here, while focusing these results, the results that is in front of you, this one is going to give us the accurate result. So we can say that the accuracy is very high over here. And also the difference is very less over here. They are somehow nearer to each other. So we can say that these, the one that is mentioned over here, this one, this one, this one, and this one, this is accuracy is very high here. Also, if I'm focusing the precision means whether the values are very close to each other or not. So you can see that the lowest value over here is 29, then 30, then 31, and 32. 31 is over here. All of these values are also close to each other. So we can say that this is highly precise. Precision is also very high over here now. Well, in another group, when I asked the same question that predict my age, the students said that I'm 41 years old. Some students said that no, 52 years old, are 48 years old. And some students said that it is that I'm almost, you can say 37 years old. So if you look over here, none of the values are nearer to the actual one. The actual one is 31 over here. It's mentioned over here, 31. So we can say that the accuracy is very low over here. And what about precision? If we are going to make it in sequence 37, 41, 48, and 52, the difference is very high. It starts from digit 3, then 4, then 5. So there's a big difference over here. So we can say that the precision is also very low in this case. But what will happen if the students are going to predict that the age of mine, some of the other group predict the age like 60, 60, 62, and 61, 65, like this one. So in this case, again, I told you the actual age is 31. So it is not accurate. So we can say that the accuracy is very low over here. What about precision right now? In case of precision, you can see that if we are going to arrange it, it is 60, 61, 62, and 65. Although these are not related to the actual age, that is 31, but these values are close to each other. So we can say that the accuracy is very high over here. So this is what the difference between accuracy and precision. In accuracy, how close you are to the actual value. In precision, how consistent a series of values are with each other. How consistent, look, these are consistent over here, this one. This is all about accuracy and precision. The next topic is about significant figure. Dear student, there are some rules that you have to follow regarding the significant figures. So if you look over here, the very first rule about the significant figures are that all non-digit numbers are significant numbers. I already solved some of the questions over here. These are related to division. So if you look over here, 23 divided by 14, it gives us 1.64285714. So all non-zero digits are significant. So over here, we have two significant figures, because both are non-zero digits, and over here again we have two significant figures over here. So what will be the answer over here, and how we can round off these values, because it's a very a lump sum, very huge number. So how we can solve it? So we will focus on these two values. In both of these two cases, we can see that there are two significant figures over here, two significants here. So we will focus on the two significant figures here now, that is 1 and 6. And we can round it off with respect to the next value next to this one, So you can see that if the next value is 5 or more than 5, so you can change this one, the 6, with the higher values. So if this one is 4, so it will remain the same. So our answer will be 1.6 over here. We have to convert it into, we have to round it off, and we have to convert it into two significant figure. In the second case, if you look over here, we have three significant figures here, 2, 4, 1 in this case, 3, 1, 2, both have three significant figures here, 3 here and 3 here. So if we are focusing over here, so in this case, we have 1, 2, and 3. Three significant figures we have to take over here, and then we have to round it off with respect to this one. As you know that this the value over here is 4, so these two will remain same. So our answer will be 0.772. This will be the answer over here now. While in the third case, if you look over here, there are four significant figures here. 1, 2, 3, 4. Four significant figures are here. In this case, there are 1, 2, 3, 4. Four significant figures are over here now. So we will focus the significant figures here with respect to this one, 4. 1, 2, 3, 4. And we have to round it off with respect to this one, and this is 5. So it means that this 0 will convert into 1. So the answer will be 1.181. This is our answer. And if we are talking about the last one, the last example regarding the first rule, 1, 2, 3, 4. 4 significant figures are here. 1, 2, 3, 4. 4 significant figures are here. So we will focus here 1, 2, 3, 4. And then we will round it off with respect to this one. So the answer over here will be 3, 5, 2, 1. This will be the answer. All these are related to division over here. So we have to focus the number of significant figures, and then we have to round it off, and we have to make it more and more simple. We have to reduce the rest of the figures over here. While in case of the same rule with multiplication, how we can solve it now? Again, we will focus on these numbers, significant figures. We have two significant figures here, and we have two significant figure over here now. So we will focus this one with respect to the two significant figure, and we have to round it off with respect to the one that is in front of 5 now. So it will be 1, 6. The rest of the two digits will convert into 0. So this is how we have to convert it into significant figure. And in case of this one, 1, 2, 3, 4, we have 4 significant figures here. 1, 2, 3, 4, we have 4 significant figures here. So we will focus on 4 digits over here, 1, 2, 3, 4, and we will convert the next with respect to the digit in front of 4. So it is less than 5, so it will remain same, 8, 4, 1, 4, and the rest of the digits, these one will convert into 0. This is how we have to convert it into significant figures. While in case of this one, again, there are 4 significant figures here. And now look, this is different now. If over here in the first one, we notice that there are 2 significant figures in the first one, 4 significant figures in the second one, while in the third examples, we have 2 different significant figures. The first one is 4 significant figure, the second one is 3 significant figure. So how we can round it off over here now? So the answer is that we will take the lowest one, the 3 over here. So over here, 5, 0, 1. So we have to convert it with respect to this one. So the answer will be 5, 0, the 1 will convert into 2, and the rest of the digits will convert into 0. So this is how we have to take the multiplication in terms of significant figure. If both of the values are different, we will take the lowest one. Now just in rule 2, significant figures, the second rule applies like this one. 0, when the 0 is sandwiched between non-zero digits, the numbers are always significant. The 0 is now in between non-zero digit. We will take this 0 as a significant figure right now. The case of 0 is a little bit different. We will discuss in some other examples. Sometime we will take it significant figure. Sometime we will not take it as a significant figure. But the second rule applies that when the 0 is sandwiched between non-zero digit, we will take it as a significant figure. So over here, we have 3 significant figures. In the second one, 1, 2, 3, 4. The 0 are sandwiched in between 2 non-zero digits. So this one is also a significant figure. So there are total 4 significant figures here now. In this case, 1, 2, 3, 4, 5, 6. We have 6 significant figures. Over here, the zeros are sandwiched in between the non-zero digits. Also, if you look over here, 1, 2, 3, 4, 5, 6. So 6 significant figures over here. But here now, in this case, you can see a decimal point over here. Decimal point is also mentioned over here. So if the decimal point is there and the zeros are in between it, we will take it as a significant figure. 1, 2, 3, 4, 5, 6. In this case, again, we have 6 significant figures. But if I'm moving towards the rule 3, the 0 that come before all non-zero digits are never significant. For example, if you look over here, the 0 that come before all non-zero digits. Look, this is non-zero digit, non-zero digit, non-zero digit, and the zeros are over here now. So if the zeros came before the non-zero digit, we will not take it as a significant figure. So in this case, we have only 3 significant figures. Well, if you look over here, again the non-zero digits are here, and then we have 0 over here. We will not take this 0 as a significant figure. Again, there are 3 significant figures over here. In this case, we have only 2 significant figures over here, because before this there is no any non-zero digits present over here. But if you will compare this one with the one over here, look, dear student, before this 0 we have non-zero digits over here. That's why we took it as a significant figure. Now, dear student, what will happen in this case now? Significant figure, rule number 4, 0 date comes after non-zero digit. Let over here, if you look over here, this one, if the 0 comes after non-zero digit like this one, so we will take it as a non-significant figure. So in this case, we have only 2 significant figures, while we will not take this one as a significant figure. So it means that there are 2 significant figures over here now. Now in this case, again, if you look over here, the same values is here, but with a decimal point. The decimal point is mentioned over here now. In this case, if the decimal point is mentioned, so we will take 0 as a significant figure. So 1, 2, 3, 4, 5. We have 5 significant figures over here now. And in this case, we have a decimal point over here, and then we have zeros next to this one. So we will say that we have only, in this case, we have, so we will take these 0. When the 0 comes after the decimal, we will take it as a significant figure. So in this case, we have 5 significant figures, 8, 3, and then there's a decimal point. And after that, when the 0 will come, we will take it as a significant figure. Again, there are some examples here. In this case, we have 7 and 8 without decimal points over here, and the 0 came after these, the non-zero digits. We will not take it as a significant figure. Only 2 significant figures are here now. In this case, the 0 came before the decimal, so we have 3 significant figures over here. And in this case, again, there is no decimal point over here, so we will not take this one as a decimal. As a significant figure, so we have only 1 significant figure in this case right now. Dear students, some of the parts are also mentioned over here in your textbook, figure 3.3. You have to go through all these rules here. The one I described over here in the whiteboard also. Again, if you're facing any sort of difficulties, you have to ask questions in the Zoom live session, also in Schoology discussion forum. You must go through these significant sample problems from your textbook. You will understand it and solve this one at home. This is your homework. You have to solve all this at home, take a snapshot of it, and you have to upload the homework in the Schoology homework folder. Thank you very much, dear student.